Welcome to my video course on AI application for railway signaling. Today, we're really standing at the edge of a massive, industry-wide technological shift. We are moving away from traditional, purely mechanical systems and entering this totally fascinating new era of autonomous cognitive networks. It is such a thrilling time to be looking at railway infrastructure, and we're going to guide you through exactly how artificial intelligence is making this incredible transformation a reality.
So, let's take a quick look at our agenda. First up, understanding deep learning. Second, convolutional neural networks. Third, computer vision and signaling. And finally, number 4, generative AI copilots. We're taking you all the way from the big macro concepts right down to the micro applied science of railway engineering.
All right, Section 1, Understanding Deep Learning. So, what actually drives modern machine intelligence? Let's get into it. You often hear terms like AI, machine learning, and deep learning used completely interchangeably out in the wild. But actually, deep learning is a highly sophisticated subset. Think of it like nested dolls. Deep learning sits entirely within machine learning, which itself is just one piece of the broader category of artificial intelligence. So they aren't just synonyms. Deep learning is really the specialized engine powering the most advanced capabilities we're seeing in the world today. The absolutely crucial point here is understanding how it works under the hood. Deep learning uses self-adjusting mathematical networks that are actually loosely inspired by the biological neurons in the human brain. Think of it like a biological process. These networks ingest just massive amounts of unstructured data and process it through multiple different layers. And here's the best part. Rather than needing a human being to sit there and meticulously program every single rule, each layer autonomously learns increasingly complex features. It adapts, it adjusts, and it literally learns its environment all on its own.
Moving right along to Section 2. Convolutional Neural Networks, the key to advanced train automation.
Convolutional neural networks, or CNNs for short, are absolutely the undisputed champions of computer vision. These are highly specialized algorithms designed specifically for image and speech recognition. You see, instead of looking at standard tabular data, like a boring Excel spreadsheet, CNNs excel at extracting features directly from raw pixel arrangements. This is quite literally how we teach a machine to see the world.
Now, when a CNN looks at a digital image, it obviously doesn't see a picture the way you or I do. It sees data formatted as a 3D array. It evaluates the height of the image, the width, and a depth of 3 color channels, specifically your standard red, green, and blue. It meticulously evaluates the intensity of every single pixel, assigning it a numerical value from 0 to 255.
So how does the network actually make sense of all those visual pixel numbers? Well, first, it uses multiple detectors for pattern recognition. Then, it performs something called dimensional reduction across its layers. This is a huge deal because it allows the network to identify features regardless of where they happen to sit in the frame. And it successfully adapts to changing lighting conditions. It's an incredibly robust process. The network can accurately recognize an object even if it's shifted to the side, at a weird angle, or cast in deep shadow.
Let's talk about that dimensional reduction a bit more. It essentially shrinks the data down to just its most essential geometric features. This process lets the CNN isolate unique patterns, for example, the very specific trapezoid shape of railway tracks converging in the distance, without requiring massive, unsustainable amounts of computer processing power. Basically, it filters out all the background noise and focuses only on what actually matters.
Okay, Section 3, Computer Vision in Signaling. This is where we graduate from the abstract math into applied, real-world rail engineering.
By utilizing these super advanced object detection techniques, things like semantic segmentation and instant segmentation, we give modern trains the autonomous capability to actually interpret their physical environment. They are no longer just blind, heavy machines rolling down a track hoping for the best. They can actively categorize the grass, the sky, the railway signs, and critically, potential obstacles. And this capability really forms the backbone of next-generation positioning. The system relies heavily on that CNN architecture we just talked about. To maintain really high accuracy, it typically analyzes exclusively single tracks at a time. And to deal with harsh, unpredictable environments, it employs thermal cameras to punch right through bad weather. Ultimately, this allows the system to instantly determine the train's precise position relative to the tracks autonomously. In practice, here's how it works. The AI model actively hunts for the track's midpoint. Now, this midpoint is localized with the help of key points that were manually labeled during the system's training phase. By hunting for these continuously, the model constantly updates the train's instantaneous position.
And as you might expect, the closer the recorded railway track is to the physical train, the better and more accurate the positioning system performs. I want to highlight a foundational principle here. Cognitive signaling systems pursue performance improvement objectives while ensuring safety by adopting the concept of risk as low as reasonably practical. By applying these AI models, we are literally transforming traditional reactive signaling into a proactive cognitive network. It actively predicts the future state of the environment, which maximizes network capacity while maintaining absolute ironclad safety standards.
Finally, Section 4, Generative AI Copilots. How we're solving the massive complexity of railway maintenance. Think about traditional maintenance for a second. It relies on heavy, cumbersome physical manuals, totally unstructured data, and highly reactive responses to breakdowns. Something breaks, you go fix it. Generative AI copilots introduce a completely new, proactive era. We're talking about digital twins and structured, instantly accessible insights. It's a fundamental paradigm shift from waiting for things to break to actively preventing them from breaking in the first place.
Having an AI maintenance copilot is honestly like having an expert assistant sitting right there on the engineer's shoulder. Because it's powered by generative AI, it can ingest mountains of physical manuals and complex documentation in seconds. It delivers step-by-step diagnostic instructions on demand. You can literally ask it troubleshooting queries in natural language, meaning an engineer can just ask it a question in plain everyday English. And incredibly, it integrates all of those answers with live asset telemetry data coming directly from the physical tracks.
But let me be absolutely clear. This technological leap does not replace the human worker. Actually, scratch that. It completely amplifies their engineering excellence. By supporting our workforce with predictive analytics and continuous data monitoring, human engineers can drastically shorten the recovery times for critical wayside systems. And that ensures the trains keep moving and passengers stay safe. Furthermore, generative AI rapidly accelerates the creation of digital twins. If you aren't familiar, a digital twin is a real-time, AI-powered virtual replica of a physical railway asset. We use these for optimization, training, and simulation. This is a total game changer because it allows rail operators to test out capacity virtually, simulating countless scenarios and training their AI models safely before they ever deploy a single piece of code to the physical track.
So, as our networks make this monumental transition from mechanical hardware to cognitive, self-learning software, I want to leave you with this question to ponder. How will the evolving partnership between human engineers and self-adjusting neural networks continue to push the absolute limits of rail capacity? The potential here is just massive, and honestly, we are only just scratching the surface of what's possible.
Thanks, we can see you next video.